Hi, I am the smuggler, and this is a barcode reader, as you can see. This is a piece of paper with a bunch of barcodes on it, and when I combine the two, something interesting happens. Yeah. Now, there's no magic happening in the background here. This specific barcode that I made tells the player to go to Chapter 2 and start playing the video. But how, and more importantly, why, does this exist? Well, that's what I've spent the last year and change trying to figure out, and I'm going to spend the remainder of this video explaining what I found. I've uncovered secrets never before seen by the internet. I've talked to people involved in development of this arcane technology, and I've reverse engineered the methods of reading and developing the barcodes used with these systems. This is a tale never told before. This is technology is the practical application of science. Technologies, whatever they might be, are created by people to solve perceived problems. Oftentimes the problems are persistent and never really go away, in which case the technology is improved upon consistently and developed into the future. Less often, though, some problems just cease to exist, and the technology used to solve that problem is rendered redundant. So what happens when the problem the technology was created to solve no longer exists? Well, that technology dies. This video is about the LaserDisc Barcode Programming language. By the time this technology was developed, the problem it was supposed to solve was already disappearing. Imagine for a moment that the year is 1989, and you're working for a large international real estate firm. Oddly specific, I know, but humor me. As part of your work, you start looking to buy a new computer. The model you settle on has everything you want. It's the IBM PS2. Not that PS2, but the other one. The first IBM system to include Intel's 8386 chips, and it has a 40 megabyte hard drive, VGA graphics, and you really care about having lots of storage, so it includes a 3.5-inch floppy bay. The 3.5-inch floppy bay has significant advantages to its larger 5-inch counterparts at the time. Not only is it physically smaller, but it boasts double the data capacity, clocking in at a whopping 2 megabytes. Walking out of the store with your new computer in hand, you hop in your affordable vehicle and drive back to your detached home, which you can afford on a single salary. What a time to be alive. The next day, a coworker from the head office requests an inventory copy of every real estate listing, legal document, and photo your office has on file. Only a few problems. The head office is in another country, JPEG photo compression won't exist for another decade, and you have over 100,000 different documents and photos on company record. You have three options: photocopy and mail it all, scan everything to 10,000 floppy disks and mail those instead, or print a couple of laser discs. This oddly specific example was one of the proposed use cases of the Pioneer LaserDisc barcode system. Since a CAV LaserDisc could store 54,000 frames per side for up to 30 minutes of video, there was no reason why those frames couldn't also just be entirely made out of still images of documents and pictures. Companies could contract small batch LaserDisc prints for a cost of a couple $100 per disc. Now, adjusted for inflation, that's still the cost of a Toyota Corolla, but compared to buying thousands of floppy disks circa the early 90s, this actually made a lot of sense. It was the difference between buying a single car or buying 1,000 bicycles. Logistically, it was just easier to deal with. Limited run LaserDisc prints had a variety of uses, including product demonstrations, marketing material, employee training, technical documentation, and general education material, reference images and blueprints, but also everything else that you could possibly want to fit on a Polaroid circa the 1990s. But why was LaserDisc considered an alternative to floppies for the purposes of storing static images over something much cheaper, like, say, a VHS tape? Well, the answer is simple. Much like VHS tapes, LaserDiscs are analog, and the information on them needs to be read in real time. VHS requires both the read head and the tape to move in order to display a full picture. That's why when you pause a VHS tape, the video kind of looks like junk. The head is spinning, while the tape has stopped its movement along the video head. This results in only half of the video information being read from any one section of the tape. When you pause a CAV LaserDisc, however, CAV stands for constant angular velocity, the LaserDisc keeps spinning at full speed. Since each half of the LaserDisc contains half of the visual information, when the laser inside the machine stops moving along the disc, it results in a perfect still frame image. DVD and CD players are also capable of this. However, it's different since the digital information is read from the disc and stored into buffer memory before being displayed. Once the video information is loaded into the frame buffer, since the player just remembers the frame info, the disc spinning kind of just becomes redundant, and you can power down the rest of the player while displaying a full image. This digital buffering was a key feature of DVDs and CDs. Things like bonus features, automatic programming, video looping, subtitles, and remote controlling them from a computer were all made rather trivial. But for the briefest of times, before DVD, we existed in this liminal space, a confusing world where the future of media formats was uncertain. That's where LaserDisc Barcode comes in. In order to overcome the limitations of analog media, and to keep LaserDiscs relevant in an increasingly digital world, the people at Pioneer devised a clever solution. Simply add a layer of computer logic onto the analog video systems. For the time, it was very smart. The computer logic board was just kind of bolted onto the existing LD player, and, if I could explain it simply, was just a really smart remote control that was built into the device. This smart control board within the player could interpret pre-made barcodes and RS-232 commands from an external computer to execute commands, a precursor to more sophisticated digital interactions we take for granted today. The idea was that you could print off a bunch of barcodes on a sheet of paper and just start going to town. These barcodes include a string of instructions which the player would perform in sequence. For example, now, this is where we can start to get into the fun stuff, but first allow me to explain the equipment. So, the V-Series is Pioneer's naming convention for professional players. CLV 2200, 2400, 2600, 2800, lots of them. The V2000 and 5000 series specifically were LaserDisc players which came equipped with the LaserDisc barcode systems. As a brief aside, in Japan domestically, the V was dropped from this nomenclature, so if you want to proxy ship a player, you'll need to search CLD 2400 or LD 2400. That's the one issue I ran into when trying to source some of this equipment. So, this is my LD V2400. It's broken. The eBay seller shipped it with a disc inside and let it bounce around in a cardboard box. So if my 2400 is broken, how am I supposed to do a demonstration? Well, ye of little faith. By sheer stupid luck, I was able to find this. The Pioneer DVD V7400. But Smuggler, that's a DVD player. That's not a LaserDisc. Well, my uncultured friend, let Daddy Smuggler explain. This is the only DVD player to ever be backwards compatible with the LD barcode format. Well, there were others, but this is the one that doesn't suck. So, under normal circumstances, it functions as a very well-equipped professional DVD player. But when used with a Pioneer barcode scanning remote, it functions exactly the same way an old LaserDisc player would. It does this by emulating the way in which those expensive LaserDisc players worked with CLV and CAV frame stores. This is made easier by the fact that fundamentally DVDs are still just spinning discs at the end of the day, and DVDs are really weird like that, since while they are a digital format, DVD players were developed during a time in which they legally were required to be compatible with analog video standards. This is partially why weird shit like HD DVDs needed to happen, since the original DVD format was taken out back and beaten into submission until it adhered to NTSC video standards, despite the fact that 3.7 gigabyte DVDs are fully capable of storing HD video files. It is incapable of playing those same videos as a DVD. Tangent aside, the V7400 was created specifically to help people transition away from LaserDiscs, while still letting them use the thousands of barcodes they had likely printed off over the last decade. And this convoluted family tree makes this DVD player one of the strangest pieces of video hardware in my humble and correct opinion. But this wouldn't be my YouTube channel if I just talked about it. So let's actually try to use these things. There's just one big problem. Nobody has cared about these things in over 20 years, and even during the peak, these weren't exactly glamorous machines. More likely, university professors couldn't wait to get rid of these things once PowerPoint presentations were invented. So the programs people use to generate these barcodes have been dead media for the better part of a decade. So in order to use the full functionality of this device, we're going to need to resurrect a dead programming language so we can create our own barcodes. So that's what I did. This is my very own barcode Bible. With the help of my good friends in the Laser Discord, we were able to compile enough information to reverse engineer the command logic which creates these barcodes. But it's not a one-size-fits-all. There are different kinds of barcodes depending on the complexity of the command you're trying to execute. The outlines are as follows. Direct commands typically correspond to the buttons on the remote and are 4 digits long. Well, the first digit, 2, in this case, is the identifier for LaserDisc Barcode 2. DVD barcodes are a little different, but we'll get into that. The second digit, 4 or 3 in these examples, references the level at which the command executes. This makes more sense when you think about the order that the LD player needs to do things. Start is the first thing a player needs to do before anything else. Stop is the last thing it can do. This process involves the player grabbing a disc from the tray and loading it. It's the lowest level, so they have the number 4. The next variation of the second column is 3. 3 is the next level up. It represents the buttons on your remote control. It automatically performs the start command if it hasn't already, and it proceeds to execute the desired function. The third column is what's actually going on. 0, 1, 2, or 3 in this case specifically. This number is contextual, and its function changes based on the first 2 digits, but it might be helpful to imagine that each button on the remote has a number that can go into this column. The last digit of every code is a check digit. It's not based on any fancy algorithms, but it's just the last digit of the sum of the other digits. So, if you added the numbers together for this play code 230, the answer is 5, since 5 is the last digit of the sum. If all the numbers in a long code add up to 97, the last digit that you add on that code will be 7. 21XX means audio, so this would vary based on the disk, but it supports digits 0 to 9, with 0 being the mute button and 1 to 9 being the audio track selector. So 2158 is the code to select the left channel on the digital audio track. 22XX means video, so 2215 means video on. 2204 means video off. All of this does kind of sound like a mess, but the important thing to keep in mind is that in this case the last digit is completely redundant. It gets added on or calculated after the fact. The digits before that are the ones that actually mattered. So the real codes are 221, or 221, or 231, or 223, whatever. The last digit just gets tacked on at the end. I hope that makes sense, since I'm going to contradict myself. This pattern holds true for the 4-digit codes, but once you start messing around with advanced functions, the number patterns change again. Fascinating, I know, but bear with me. So when you enter in a 6-digit command on the LaserDisc, you kind of ignore the rule I talked about for the second column number, since once you enter a 6-digit command, the player makes some assumptions. Anything beyond a 4-digit code puts the player into something called random access mode. Since the disk is already playing, any point in the disk now becomes available to these barcode commands. 6 digits on a LaserDisc barcode initiates a chapter search. This automatically loads the disk, finds the chapter, and starts playing that designated chapter. So, the code 206079993 goes something like this. 2 means LaserDisc Barcode Standard 2, 06 means go to Chapter 6, 07 means Chapter 7, 99 means play until, and then 3 is the check digit. So, quiz time. What does this code mean? 2, 14, 15, 99, 1. Well, this is the same as the last one, only we're going to Chapter 14, and we're playing until Chapter 15. Awesome. Now you can generate your own barcodes for use with commercial LaserDisc players. Enjoy this moment because once again everything gets totally messed up when this system is formatted to interact with DVDs. 6-digit chapter play commands from LaserDisc turn into 12-digit commands for DVDs. So a code that is 401 112 1701 298 is something like this. 4 is your DVD barcode. 01 is your title menu number. 12 is searched chapter 2. 17 is play to chapter 17. 01 is subtitle track 1. 2 means audio track 2. 9 is angle select, but 9 specifically means that there is no change, or it stays at the default if you've already specified some other change or nothing's happened to it yet. This is useful for multi-angle DVDs, but I don't think very many of those ever ended up getting printed. These are DVD 12-digit commands, which are for a chapter segment play. This code serves the same purpose as an 8-digit LaserDisc command, but it has room for additional options that are specific to DVD, specifically subtitles, title menu selection, etc. A 6-digit attribute control command gives us access to these features. For example, a 6-digit attribute control command is very similar to the LaserDisc 4-digit commands, in the sense that it gives us access to the basic functions of the DVD player without worrying about where in the disc we need to be or what we need to do. So if you wanted to control audio, subtitles, or even, I don't know, just random DVD menu things, you could use a 6-digit control to execute that. So for example, 402196 is essentially 4 stands for DVD, because DVD is the 4th iteration of the LaserDisc barcode system. 02 is subtract 2, 1 audio track 1, 9 angled default, and then 6 would be your check digit. And that will essentially enable subtitles on the second subtitle channel if you have a anime disc, and put the audio on audio track 1. So for 402196, this code will enable the second subtitle track, audio track 1, but this will vary depending on the number of tracks available. If you wanted to watch subtitled anime with Japanese audio on a normal dubbed DVD release, you would want this code, 401296, subtrack 1, audio 2, angle default, check digit. This code, 400194, is for subtrack 0, audio 1. So if you don't have a subtitle on track 0, and you're already playing subtitles, it will just turn them off. So codes can function differently depending on the situation. For my anime DVD, this one plays the English dub with no subtitles. The digit 9 in these codes corresponds to a no change command on the angle. So with 9 being a no change command, if you wanted to change the audio and keep subtitles the same, your first 3 digits would be 499, since that would just assume whatever's already going on. These 6-digit attribute commands can be created to provide specific macro controls for frequently used functions, and would have historically been used to quickly mute or change audio tracks during a PowerPoint presentation. When used in combination with other commands, they can be quite versatile. For example, if you're giving your video presentation, you can make a command to play the video on a loop. The second time the video plays, you can scan the barcode to mute the audio and proceed to narrate or explain what the video is doing while it continues on its original loop. The original V-Series LaserDisc players had something called the repeat function, which could enable this functionality over the RS-232 connection on the back of the player. The DVD players have some of these RS-232 functions made possible without a computer using something called the barcode command stack. Mastering the barcode command stack will allow you to turn one of these players into a non-linear video editing console. You would do this by using something like the 10 to 14 digit commands, which tell the player to go to predetermined sections of video and what to do when they're there, which is what I'll show you how to make now. This is a 10-digit chapter search command. So in this case, 4 means DVD, 02 means title menu number 2, 05 is your start chapter, 6 is your end, 1 is your subtitle track, 2 is your audio track, 9 is your video angle, meaning default, and then 9 is your check digit. As you can see, this is just a 6-digit code. with an extra 4 digits added at the beginning to tell the player where to go and how long to go for. But this only gets us to navigate from chapter to chapter. Some DVDs don't even include chapters, or in the case of a TV episode, may only have 2 or 3 chapters for the opening theme song and mid-roll commercial break. So, in order to get the most out of this system, we need to be a bit more precise. A 14-digit frame search command is definitely the way to go. On LaserDisc players, this is a 10-digit command. So, if we want to search frame by frame, we need a code that looks like this. 4 is for DVD, 01 would be your title number, your next 6 digits would be your start frame, so 000, whatever it happens to be. Your next 6 digits after that are your end frame, so you would be specifying a chunk of video to play. And then your last digit is your check digit. So if we had a 6-title disc, meaning 6 different chunks of video inside of the disc, and we wanted to search the same frame range for each chunk of video, maybe to compare what it looks like or to make visual references, we could just generate the same series of codes with different title numbers, which would look something like these. Keep in mind that the specified frame range cannot be less than 25 frames. This is a limitation of the MPEG-2 container format that DVDs utilize. The LaserDisc standard, however, could play 2-frame loops. When we try to play a frame range of 1, nothing happens. So if we want to go to a specific frame and not play the video any further, what we can do is start the video loop 25 frames earlier than the spot we want to look at. And congratulations, we just made a PowerPoint presentation using stacks of paper. So all that's left is to have some fun and play around with these things for a bit. Which is what I would say, but first we have to make ourselves some custom DVDs. I already made one for this video, but I'll go over the process I used briefly. Now, while it's easy to Google free DVD burning software and download the first thing you find and give your computer chlamydia, I'm not going to do that to myself again, so I found another program. Professional DVD authoring is a long-dead technical skill that requires an understanding of analog and digital video, as well as the janky world of early internet-era video compression. Fortunately, we are not professionals, so I'll just show you what buttons to push and we'll be on our way. First, find some low-resolution NTSC or PAL standard definition footage. 4x3 or 16x9, doesn't matter. The program I'm using is actually free, open source, and quite comprehensive. It's called AVS to DVD. It's a very dusty program, but unlike many of the options available, it actually works in our year of the Lord 2024. This program does require a working AviSynth installation, but if you can install AviSynth, the rest of this stuff's just kind of easy, really. So, drag the files into the program, mess around with the images in the templates folder if you want to customize the menus, and send it. Use image burn to create an ISO file, or select an option to burn directly to disk. Spin up your disk burner, and you're good to go. Now we have a playable disk. Importantly, the individual video files are loaded as separate titles inside of the DVD's menu. This divides the video into chunks, which means that we can navigate easily between them using the barcode system, and have them organized and set up just the way we like. The reason burning your own DVDs is so valuable is that you can format your video files specifically with the barcode format in mind, essentially allowing you to create your very own educational discs, just like they would have back in the day. But there are some issues with only having one of these players. If you wanted to do something like advanced program transitions and A to B roll video editing, you would need 2 of these players, which is why these players were designed to work in pairs. Some of the features are actually only functional if you have 2 of them, and in fact, Pioneer had a completely separate product that they sold under a different name, which was just 2 of these mounted inside of a 19-inch rack. So in light of this, I purchased 2 of these devices.